Hello and welcome to MindSpark, Science Now. I'm your host. And today we're diving straight into one of the loudest claims on the tech horizon. Can Elon Musk's newest AI really learn anything in just 10 seconds? It's a line so catchy it practically writes its own headlines. But what does it actually mean, and is there any truth behind it? Over the next 6 minutes, I'll walk you through the myth, the machinery, and the measured reality behind Musk's two very different artificial intelligence efforts: the language-driven Grok models at Shy, and the embodied systems, full self-driving, and the Optimus robot over at Tesla. Setting the stage. Back in late 2023, a startup called xAI burst onto the scene with Grok 1, a text model that styled itself as bold, unfiltered, and lightning fast. At nearly the same moment, Tesla's humanoid robot Optimus appeared on stage, stacking boxes after watching only a short demonstration clip. Somewhere between those two flashy rollouts, a legend was born. 10 seconds. Universal learning. Instant mastery. It sounded like science fiction, and frankly, it is. To grasp why, we first need to separate fast responses from true learning. xAI's Grok. Speed versus understanding. Today, Grok has evolved through several versions: Grok 1.5, 2, 3, and the current flagship, Grok 4 Heavy. Rumor pegs Grok 4 at roughly 2.4 trillion parameters and a staggering 256,000 token context window. All this is trained on a GPU supercluster called Colossus, 200,000 H100 class. Chips humming away in the Nevada desert. Now, that scale lets Grok do incredible things. Drop a 100-page legal contract into the model, and it can highlight any clause you ask about in just a few seconds. Ask a tricky coding question, and it can draft working Python almost as quickly. But here's the crucial point. Nothing about that speed means the model is learning new principles in 10 seconds. Instead, Grok is retrieving and reasoning over skills baked into its billions of internal weights. Weights that took weeks of training and petaflop seconds of compute to create. Updating those weights meaningfully, even for a single gradient step, still requires minutes or hours on Colossus, not the snap of a finger. Tesla's embodied AI, robots and robotaxis. Switch scenes to Tesla. On the road. Full self-driving version 13 now replaces hundreds of thousands of lines of legacy C++ logic with a single end-to-end neural network. It perceives the world purely through cameras, refreshes its vision stack 20 times per second, and delivers smoother turns and merges than ever before. Regulators remain cautious, but the progress is undeniable. In the factory, the Optimus humanoid robot watches short human demonstration videos and then performs tasks like folding shirts or stacking parts. Audiences see a 10-second highlight reel and assume Optimus learned on the spot. In reality, the robot's core brain is trained offline on petabytes of fleet video. The live demo merely fine-tunes or re-ranks existing skills. The heavy lifting happened long before the cameras rolled. Why the myth persists? So, how did 10-second learning become a talking point? Latency looks like magic. Grok often produces an answer in under 10 seconds because it queries a search toolchain in parallel with text generation. That blazing retrieval speed blurs the line between recall and learning. Long context wow factor. Hand Grok a book-length PDF. It digests and summarizes it almost instantly. Impressive. Yes, but again, that's pattern recognition, not new knowledge formation. Cinematic editing. Tesla's marketing packages months of training into bite-sized video snippets. Viewers connect the clip length with training time and walk away convinced of spontaneous mastery. What can actually happen in 10 seconds? To be fair, Musk's systems do achieve remarkable feats inside that short window. Grok can ingest a 100-kilobyte document in about 8 seconds and answer detailed questions right away. Full self-driving refreshes its perception stack multiple times per second, constantly recalculating safe trajectories. Optimus can replan its next move on board every few milliseconds, drastically cutting reliance on a human teleoperator. These are examples of rapid inference and context adaptation useful. Powerful, but fundamentally different from learning entirely new skills. The road ahead. Looking forward, 3 forces will shape whether the myth fades or becomes tomorrow's reality. Compute economics. Colossus won't stand still, but neither will competing GPU farms. Whoever sustains the fastest hardware upgrade cycle may dictate the pace of model growth. Safety and regulation. Missteps like Grok's infamous mecha incident expose lingering guardrail weaknesses. Each public failure invites stricter oversight, potentially throttling release cadence. Real-world utility. For Optimus to move beyond the demo stage, it must handle household or factory tasks cheaper than a human worker. Till then, it remains a science. Project turned showpiece. The takeaway. So, can Elon Musk's AI learn anything in 10 seconds? No. If learning means updating its core parameters with durable new knowledge, the compute cost alone keeps that out of reach. Yes, partly. If learning means absorbing a new fact or adapting to freshly provided context, within its massive pre-trained framework, Grok can pivot to a new topic almost instantly. And Tesla's robots can refine their action plans in milliseconds. In short, the 10-second claim is marketing shorthand for fast retrieval plus clever adaptation. The real magic remains the slow, resource-hungry training process no video montage wants to show. Thank you for joining me on MindSpark. Science now. If you found this exploration helpful, share the episode and leave a review. Most of all, stay curious. And remember, 10 seconds is perfect for clicking follow. A genuine understanding still takes a bit more time. Until next time, this is your host signing off.